Alright, so we have this question, minimum add to make parentheses valid. So basically what we have to do is that we have to tell that how can we make the parentheses valid. So this is very same like the question valid parentheses, wherein we had to tell if it's valid or not. I don't know what the right pronunciation is, parentheses or parentheses, whatever. So yeah, we just need to tell how many to add to make it valid. My thought process says that let's do one thing. If we can do stack dot size, which I did see uh, before this question, yes, we could do. We can do stack dot size because because stack in Java extends vector, and vector we have the lists and everything. So yeah, we can do size, I guess. Let's see. It says yes, so let's see. Not sure about the way we will be creating it. If you would be creating it using a deck or a DQ. So yeah, but I have a thought process for it as well. If we can't take out the size, we can add the elements, and then we can say that alright, if the stack is not empty, I'll have a count as 0. Keep popping the elements. When you pop, while the stack is not empty, pop count plus plus. So let's try to do this. I guess it's a very simple question. It says medium, but I guess it's very simple. Let's try to do it. So first of all, let's create a stack. Yeah, let's create a stack of character type, that is st equals to new stack, right? Then we can have a for loop. I'll have a enhanced for loop because I don't care about the index. I'll say from s dot to char array, s dot to char array, and then what I'll do is I'll say alright, if I have elements as if c equals all the openings, yeah, if c equals this, do this, right? Yeah, opening brackets, on opening brackets you have to push into the stack. You have to push c into the stack. Alright, if we have these things, push it into the stack, else do one thing. Yeah, else do one thing. If that is not the case, then what you can do is you can say that alright, I don't have them into the stack. So if we are not getting it, we'll check if it's empty. If dot is empty, if it's empty, you have to return false. I mean, you have to return then we can't complete a stack. If you're getting the, suppose we have an opening and a closing, if you are only having closings, we can't complete it, then we're going to return -1. I guess that's what they ask. If a parenthesis string is valid only if and only, and see, if it is starting with the closing, alright, if it's starting with a closed bracket, I can't do anything about that, so I'll have to return 1. If the first bracket is a closed bracket, I can't complete it no matter what. So it's not a, I can't make it valid. That's the point. So I'll return -1, and then if c equals, now the closing bracket, if c equals this, yeah, we can have top right here, char top, not making the mistake I made in the while parentheses, st dot pop, yeah, if I have the top right here, I'm gonna store the popped element into the top, and I'm gonna be like, and top not equal, when like top is not if C is the this bracket, and if top is not equal to this, the opening bracket, if C is, now if I encounter C, if that C is a closing bracket and the top, the one that is popped off from the top is not the opening one, then I'll have to, you know, what I have to do, I guess I'll continue. I don't know how to, I'm not sure about the handling of this case. All I'm saying is wait, I can do one thing. If C is this and top equals this, I can say, wait. If suppose top is not equal to this, if on a closing bracket I don't encounter, let's have all the if conditions first, right? Let's have all the if conditions. Yeah. So if the top is that, and if my top is this, my bad, not top, but yeah, whatever. If top is not opening, but I have a closing, let's see what to do with these cases. All right. We know one thing, that if my now current character is on a closing bracket, for example, there has to be an opening bracket, right? There has to be an opening bracket that has to be there no matter what. Yeah. So the thing is that if I push those elements, suppose for test case 1, if I push it, I encounter this, I pop it, right? Hey, it's fine, I pop it, it's fine, cool. And then I have a closed bracket. Yeah, that was the thing. I thought that I can't do anything with the opening, but that's not the question. Alright, wait, I have a idea. I'll have int count that is equals to 0, and then I'll say if stack is empty, and if any element is trying to enter in an empty stack, don't do anything, just say count plus plus, that's it. Alright, if this is not the top, if I alright, we have two examples. How can we deal with them? So first of all, I thought that if you are starting with an closed bracket, the case is hopeless, but no, you have to return the count anyhow. So alright, the thing is, I'll do one thing. Yeah, let's remove this top thing. Cool. I'll be like, if C is this, yeah, if C is this, and st dot peak equals to opening, cool, st dot pop, remove that element, cool, remove that, let's copy this, I don't need that element, that's it. Closing, yeah, Cool. I'll remove them. Anyhow, I will remove them. Alright, I will remove them. Cool. So now the thing is that I'll have to deal with this case because, for example, if I add a close bracket, I'll first of all encounter a close bracket. Alright. So if I encounter, I'll push. Let's remove this condition for now. Yeah, let's remove this condition for now. My bad. Yeah. So what's the code is saying at the moment that, alright, if you encounter a opening bracket, cool, push it. If you encounter a opening bracket, push it. If you encounter an opening bracket, push it. If you don't encounter an opening bracket, but you encounter you know, a closing bracket, and if you find that on the peak opening bracket, pop that thing. It's fine. It's very much fine, I would say. Yeah. But now the thing is that let's handle that case initially. Yeah. If st dot is empty, if the stack is empty, and do I put and? I mean, I want to make a case in which the stack is empty. You know, the stack is empty, but you put in the element that is the closing bracket. If stack is empty, yeah, and if C equals to a closing bracket like this, or I'll change that, or this. So if C equals to, wait, what happened? What have I copied? It's fine. Wait. Nope. C equals a closing bracket like this. If the stack is empty and it's encountering a closing bracket, but now the case is if it won't be empty, then what to do with the closing ones that I'm encountering? That is something to think about. Alright. Wait. Oh goodness. I just read the constraints and I am a fool. Why am I dealing with all the subcases when I can focus on one? Why? Thank God I read it before anything. Cool. Let's remove them. That's fine. So now the thing is that, see, I'm like, let's ignore this for now. So I'm like, all right, I have a C, it gets a value, I push it in, yeah, and if I don't get it, what do I do next? So if I don't get this thing, I go to the else block, because obviously I didn't get that. So I'll go to the else block, I'll see if C is that, and if the peak element is that, the opening one, I'll pop that, yeah, and I'll encounter this edge case. I guess this will be the edge case, yeah. If stack is empty and C is this, the closing bracket initially, I'm gonna say st dot push C count plus plus. Anyhow, if I start with the empty bracket, I'll have to increase the count, because then that is the game, yeah. Okay, fine, that is sorted. I handle that one edge case if in the start it's something gonna happen with that. So now I know one thing. Like if I start like with the if thing, you know, in the if thing, I'm like, if I'm starting, so this is like handling the edge case, the first if condition. That is, let's space it out. That's handling the edge case in my opinion. Yeah. Uh, that if it's empty and you put in that value, so you have to increase the count. Cool. And if you put C in, it's fine. You put that in. Cool. All right. Uh, and if you don't encounter that, and if you encounter a closing bracket but you find the opening bracket on top of the stack, you remove that. Fine. Yeah. So after the for loop ends, what I'll do is, if I can do that, I'll say count plus, like return count plus st dot size, if I can do that. Yeah, it makes sense here. Why it's not making sense here? Output is 2, expected is 1. So initially, if first element had been entered, if stack is empty, if this is not the case, if you push it, second element, stack is not empty, so it's not gonna happen. Else condition we get into, we see if C is that, if we see S or peak is that, we pop it, it's removed. Stack is now empty. If stack is empty, I push it, count plus plus. Cool. Oh, my bad. Oh, alright. Okay. I can just do one thing, I can just say this, maybe. Yeah. I don't think it's gonna work for all the test cases. Maybe some edge case, I knew it. Yeah. Output 3 expected 4. Alright. Let's do a simplified solution for it. Cool. After this happens, while is not empty. While it's not empty, what do you have to do? Simple. All I have to do is st dot pop count plus plus. That's it. You don't have to return the size then. You have to return the count. How about that? How about that? Oh my goodness. Let's see if it works for this case. Yeah, it works for that. Cool. So, what's the error here now? What is the error here now? I guess this line is the error. What if? Because now I'm actually dealing with the size thing. Wait, what? Empty stack? How? How can I get empty stack for this? I push it, I pop it, cool. Oh, let's do one thing. Push it anyway. Like, push it. I don't care. Push it. I don't care. Push it. It's fine. Oops. Wait, what? Oh, my bad. Yeah. How about that? Should be working. Nope, not working. Not working at all. Output is coming out to be 3. Oh, I understood. So see, the thing is that uh, wait, let's get this if out. Let's do this. If let's reformat it. Wait, what? That's not a reformat. Um, wait, what is happening? What is happening? Why is while like that? Let's copy. Let's remove this. What I was gonna do, I forgot. Damn. Yeah. How is this taking? Okay. Yep. Else if I forgot what I was about to do. My goodness. Uh, I was like, I had pop right here. That's for sure. I was about to handle the edge case, I guess. Stack is empty. Because there can be a case wherein I only keep putting the closing ones. So what about that? Yeah, this case is gonna take time. Why is the while loop like that? And what is this? Yeah. Else, let's not care about stack being empty. Else dot push C. It's gonna get popped out anyway. Empty stack exception. Why is this exception taking place? Why? Wait, why can I push this thing, the opening bracket, in an empty stack, but I can't push something in a like a closed ones in an? Well, I don't understand that. I'll have to figure out a logic for it, because it's counting it twice. If stack is empty, I'm incrementing the count, and I am also popping the elements off, so I'm also incrementing the count at that time. So it's counting it twice, but I don't understand this logic. Oh, it's saying at line 1. peak. If C is this, the closing one. Oh, actually, I'm getting a closing bracket. Oh, I understand. And I can't peak. Wait, I can have a check right here. ST is empty and then only execute this. Works. Alright, works. So that was the edge case handling in my opinion. How much time did I take for this problem? 26 minutes, it was a lot. Should have done way before, but it's fine. So yeah, the thing is, let's remove this. For the edge case handling, that is the only thing that has to be done. That is, if the stack is empty. I was peeking if the stack was empty, which isn't the right thing to do. So yeah, I add the elements and then I either, if I get a valid parenthesis, then I pop it. If not, I add them anyhow and then I pop them and I increment the count. So yeah, alright.